Hello everybody, I'm Miss G and I'm going to try to make math a little easier for you today. I don't know if I'm going to succeed, but I'm sure going to try. Okay, so we've got our unit circle, and it's a beautiful thing, it really is. It's symmetrical with repeating patterns that allow us to solve all kinds of problems, but it's also really hard for me to remember and to visualize because there's a lot going on. So I decided to turn it into an organized table. Let's start by looking at how I designed it in order to understand how the circle and the table are connected. Now, if you're not interested in how they relate or you just want to know how to write the table version, check the description below. I'll put the time for when I actually start writing the table somewhere in there. We'll look at the angles first without the trig points. We start here on the x-axis at 0. Then we go to pi over 6, pi over 4, and pi over 3 before we hit the y-axis at pi over 2 and change direction. We keep going with 2 pi over 3, 3 pi over 4, and 5 pi over 6, then hit the x-axis at pi and change direction again. We get to 7 pi over 6, then 5 pi over 4, and 4 pi over 3, before hitting the y-axis at 3 pi over 2 and changing direction. We go through 5 pi over 3, 7 pi over 4, and finally 11 pi over 6, before we're back at the x-axis where we started, except now we'll call it 2 pi. Next, we'll need the trig. But before we start looking at those trig points, let's talk about some patterns that I noticed on the table, which will help me write it later. In the three angle rows, the ones with the fractions, the top row is always something pi over 6. The middle is always something pi over 4, and the bottom is always something pi over 3. If you look at the top of the fractions, you can think of them all as either going up 1 or down 1 from some variation of the bottom. For the first column, we go up 1 from 0, or none of the bottom, which would just give us 1 all the way down and doesn't actually change anything. So honestly, I skip the first column. I don't even worry about it because it's just going to be pi over 6, pi over 4, pi over 3. But for the second column, we go down 1 from the bottom number. The 5 pi is 1 down from 6. The 3 pi is 1 down from 4. The 2 pi is 1 down from 3. The next column is going up 1 from the bottom. So 7 pi is up 1 from 6. 5 pi is up 1 from 4. 4 pi is up 1 from 3. Now for the last column, we need to do a little bit extra because each numerator is 1 less than double the denominator. So we double the bottom and then go down 1. For over 6, double 6 is 12, then down 1 is 11, creating 11 pi over 6. For over 4, double 4 is 8, down 1 makes 7, creating 7 pi over 4. For over 3, double 3 is 6, down 1 is 5, creating 5 pi over 3. And these patterns are going to be really helpful for us when we start writing and memorizing the table. But we do still need our points, which are going to tell us the trig. Let's start with our axes. The x-axis values 0, pi, and 2 pi are all at some variation, either positive or negative, of 1, 0. The y-axis values, pi over 2 and 3 pi over 2, are at variations of 0, 1. If we look at all of our over 6 angles, they are all a positive or negative variation of root 3 over 2, 1 over 2. The over 4 angles are all versions of root 2 over 2, root 2 over 2. And the over 3 angles are all variations of 1 over 2, root 3 over 2. Now that we have all of our points, we again need to look at our table to recognize some patterns. First of all of the fractions are over 2, and all of the numerators are roots, root 3, root 2, and root 1. But since the square root of 1 is 1, we just don't show the root. Another thing to notice is that for our x, it's counting down, 3, 2, 1, whereas y is counting up, 1, 2, 3. Again, these patterns will be really helpful to us when we're writing and memorizing our table. Now we have all of the information from the unit circle represented in the table. Well, that's not true. The unit circle also tells us which points are positive and which are negative, so let's deal with that. Some of your teachers might use the mnemonic, all students take calculus, which is a lie, but it's a useful lie because it gives us the setup all STC. This signifies that for the first quadrant, which on our table is the first column, all of the trig ratios are going to be positive. For the second quadrant, or column for us, only the sine is positive. For the third, only tangent is positive. And for the fourth, only cosine is positive. We also need to know the sign of our axes. And because 0, pi over 2, and 2 pi are all up or to the right, they're all going to be positive. Just like pi and 3 pi over 2 are going to be negative because they're down and to the left. But now that we've gone through the whole unit circle, I'm going to get rid of it and focus entirely on the table, because this table has everything that the unit circle offers, just organized in a different way. There are a few things that I want to add to complete it though. First, a header. We've got the beginnings of one with all positive, sine positive, tan positive, cos positive, but I want to add headers for the points as well. So I'll add cosine comma sine. I also want to add a column that isn't given by the circle, tangent. Now tangent is sine divided by cosine. So I'm just going to solve and fill all of these in. When I divide though, I'm not going to worry about the denominators. Since they're all the same, they're going to cancel out anyway, so there's no point in me worrying about them. 0 divided by 1 is going to give me 0. 1 divided by root 3, when rationalized, is going to give me root 3 over 3. I'm going to need you to trust me on this one because there's a very good reason, but if I go into it, this video will be longer than it already is. Next, we've got root 2 divided by root 2, which gives us 1. Then root 3 divided by 1, which is just root 3. And finally 1 divided by 0, which is just impossible, so that's undefined. Now this table is my version of the unit circle. It's what I memorize and what I use to solve problems. For me, this way is easier to read and easier to remember. Well, it was easier once I had the patterns understood anyway. Now that I've shown you how it all came together and how it's related to the circle, let me show you the steps to writing it when you don't have the unit circle in front of you. So we're going to start with the structure. You're going to need to use 6 lines on your paper. The header, x-axis, first, second, and third angle sets, and y-axis will all need their own line. Then you're going to create a 3-row by 4-column table for the angle sets. With the 2 empty lines above it and 1 empty line below, and we leave space to the right for our trig. Next, we're going to fill in the header. All students take calculus. All STC. So we write all positive, sine positive, tan positive, cos positive. And then for our trig section, we have the point cosine comma sine, and then our tangent. Next, we'll deal with our axes. These I just memorize. 0, pi, and 2 pi are all values on the x-axis at the point 1, 0 or negative 1, 0. On the y-axis, we have pi over 2 and 3 pi over 2, and these values are both at some variation of 0, 1, either 0 positive 1 or 0 negative 1. In terms of when they're positive and when they're negative, we're just going to alternate our signs, positive, negative, starting with the x-axis. 0 is positive, pi is negative, 2 pi is positive. And then our y-axis, pi over 2 is positive, 3 pi over 2 is negative. Next, we're going to fill in our angle fractions. The top row are all something pi over 6, then the middle is something pi over 4, and then the bottom is something pi over 3. Our first column is going to go up 1, but it's going up 1 from nothing, so I don't really worry about it. The next column is down 1 from our bottom number, so down 1 from 6 is 5, down 1 from 4 is 3, and down 1 from 3 is 2. The third column goes up 1 from our bottom number, so up 1 from 6 is 7, up 1 from 4 is 5, and up 1 from 3 is 4. Now in the last column, we're going to have to double the bottom before we go down by 1. So double 6 is 12, going down 1 brings us to 11. Double 4 is 8, going down 1 brings us to 7. Double 3 is 6, and going down 1 brings us to 5. And that's all of our angles, which brings us to our trig points. Now the main thing to remember about all of these trig points is that they're all some root divided by 2 every single time. For our cosine, we're going from 1 to 0, which means we're counting down. And that gives us 3, 2, 1. Now, the only root that doesn't actually need to be there is the square root of 1, because the square root of 1 is 1. So we're not actually going to show the root for that one. It'll just be 1/2. Now for our sine, we go from 0 to 1, which means we're counting down. 3, 2, 1. And again, we don't worry about the root because the square root of 1 is 1. The last part of the table is tangent, which you can solve for by using sine divided by cosine, but I'd recommend just memorizing it. Our tangents are going to be 0, root 3 over 3, 1, root 3, and then undefined. And that's the table. It's all you need in order to solve unit circle problems. For instance, let's say you need to know what cosine 5 pi over 6 would be. Looking at 5 pi over 6, I see that the cosine is either positive or negative root 3 over 2. Now the way I can tell if it's positive or negative is I look at the column 5 pi over 6 was in. It was in the sine positive column, which means that only sine is positive. And if only sine is positive, that means that cosine has to be negative. So our answer for cosine 5 pi over 6 is going to be negative root 3 over 2. If I wanted tangent of 4 pi over 3, that angle is in the root 3 row for our tangent, so it's going to equal either positive or negative root 3. And to figure out if it's positive or negative, I'm going to look up here to see which column it's in. It's in the tangent positive column, where only tangent is positive. But since I'm looking for tangent, what that means is that this answer is going to be positive. I would write it as just plain old root 3. And that's it. That's how the unit circle table works. I really hope that this table helps some of you with memorizing and setting up your unit circle. If you want to help me out and hit those like and subscribe buttons, I'd appreciate it. But if not, I still love you. I hope you're all having a fantastic day. Bye, everybody.